All right, this is the section 4.1, the last three examples that we still had left to go over. So let's start with part D. And we're going to be looking at, first of all, how do we determine the end behavior? Then we're going to look at the behavior at the individual zeros, and then finally graph. So just to recap, to know your end behavior, what you have to look for is two things. And you want it to be in this standard form if you're going to look for them the way I'm about to. When we get to the factored one, which is part F, remember you have to look for end behavior slightly differently. So the end behavior is determined by the degree, overall degree of the polynomial. Is it even or odd? That's if it's in the standard form. Is the highest power even or odd? And the leading coefficient in front of the highest power is going to either be positive or negative. And remember in our chart, which I'll scroll back up just to remind you of, we knew that there were four possibilities of those combinations, and these are the different end behaviors. So if you have an even degree, you're going to have things that go in the same direction. So if it's a positive leading coefficient, they're both going up. If it's a negative leading coefficient, they're both going down. If it's an odd degree, they go in opposite directions, like x cubed. So if it's a leading coefficient that's positive, it's down on the left, up on the right. If it's a leading coefficient that's negative, it's up on the left, down on the right. In other words, it flips it upside down. Okay, so let's look at this one. This has a highest power in 3, so that would be an odd. And its leading coefficient is positive 1. So that means it's going to behave very much like just a standard x cubed. So down on the left, up on the right. And then we need to now look at the zeros, which means we're going to have to set the function equal to 0. So f of x becomes 0. And we're going to factor this. Oops. Sorry about that. It always jumps anytime I use the reverse key. Let me get down to our example. So minus 3x squared, just finish writing this, minus 9x plus 27. This is 4 terms, so I'm going to try factor by grouping. Plot an x squared in the first pair, that's going to be x minus 3. Plot a minus 9 out of the second pair, that's also x minus 3. This factors into an x minus 3 that they share in common, and then an x squared minus 9 is the leftovers. And that factors again into another x minus 3 and x plus 3 because of the perfect square factoring, the difference of two perfect squares. So this is going to give me an x plus 3, x minus 3. And I like to rewrite this one more time because anytime you have a repeating factor, that has a multiplicity. So we want to make note of that for our chart, remember, to talk about the behavior. So remember, our behavior at our zeros is determined by the multiplicity, which is the number of times that the factor is occurring. And so remember, I had something called a zombie chart in class. It's not really a zombie. It's zeros, their multiplicity, and their behavior. So that's why I call it that, just because it's like a phonetic sounding of it. So this 0 would have been positive 3, and this one would have been a negative 3. We will usually want to list these in the order that we would graph them, which is from left to right, so least to greatest. This one came from x plus 3, and that had a multiplicity of 1. I don't ever write the number. I always write the word, so I don't confuse this as looking like an ordered pair. Behavior, when you have an odd multiplicity, means you're going to cross the x-axis. And this is a 3 that came from x minus 3, and that's got a 2 for its multiplicity. So that's an even. So that means we're going to touch or bounce, whichever way you want to think about that, at the x-axis. Okay, so let's put what we know down. So we have our x-intercepts of negative 3 and positive 3. We have our end behavior that is down on the left, up on the right. You do need to do that before you put any behaviors at the zeros down. At negative 3, we're supposed to cross the x-axis. That means we're going to go up. And again, we're not worried about the heights at all on these. We know that we don't actually mark the y-axis for you on the test, so we don't want you to worry about that height. And then it comes down to 3, and at 3, it's bouncing. That makes sense with my end behavior, so that's what we expected. The last piece of each of these is that you have to tell me when does the graph have y values that are greater than 0, and when are the y values less than 0, and that's, remember, related to your domain, so your x-axis. So from negative infinity up to negative 3, our graph is below the x-axis. So that goes on the less than. Oops, I don't know why that jumped just then. I did not actually do anything. So let's go down. There we go. and then it went down here. That's really weird. Okay. Computer issues. So negative infinity to -3, you're below the x-axis. From -3 to +3, we're above the x-axis. And we're also still above from 3 to infinity. But because they didn't say equal to in the directions up above, you can't combine that into one interval. You still have to skip the 3 because that is where it equals 0, not greater than or less than. And that's it for part D. So let's talk about E for a second. So again, this is in the standard form, so we should be able to tell the end behavior pretty quickly. So end behavior, we're looking for the degree of the polynomial. Is it odd or even? Doesn't matter which one of these you write first, I'm just writing them down. Is it positive or negative? The highest power in this standard form is an even, so it's a 4. And the leading coefficient is actually negative. So when you're even, you're heading in the same direction, and negative means they're both down. We're going to try to factor this to find our zeros. Usually when I have something with a negative out front, I'll pull that to the front because that helps me with factoring usually. So this looks like it is factors of 27 that add to -12. That's going to be a -9 and a -3. And you're factoring this into 2x squared because it's an x to the 4th. This one will factor again to x plus 3, x minus 3. This one does not factor because 3 is not a perfect square, but we can still solve it to get the zeros. If you set it equal to 0, you get x squared equals 3, and that's going to be a real number when we take a square root. So this one actually this has 2 different zeros in it because it solves to a plus or minus square root of 3. This gives us a -3, and this gives us a +3. So you could technically factor that line if you wanted to. It would just have radicals in it. It would have an x plus a square root of 3 and an x minus a square root of 3. So they are both separate, they're different. Okay, so let's set up our chart. Put them in order from least to greatest. So -3 is the smallest, negative square root of 3 is the next smallest, square root of 3, which is about 1.7, is the next largest, and +3. Each of these occurs only one time. No repeating factors, which means they're all going to cross the x-axis. So we have to put our graph points on. So -3, about -1.7, if you do the square root of negative square root of 3, if I can talk correctly, 1.7-ish, and +3. We're supposed to be down on both sides for our end behavior, and that's important to do before you do your crossing or your bouncing. So we're going to cross, and you can't go far because you have to head back to this next x-intercept, and we're going to cross down again, cross, and cross. So crossing at each x-intercept, and it kind of looks like an M. So f of x is going to be greater than 0 on the following intervals from -3 to negative square root of 3. That's when I'm above the x-axis there. And it looks like from square root of 3 to 3. I'm also above the x-axis. From negative infinity to -3, I was below the x-axis. From negative square root of 3 to positive square root of 3, I'm also below the x-axis. And from 3 to infinity, my graph is below the x-axis. So you use those x-intercepts to help you break up your interval notation. All right, the final one, and that will get us caught up on this section of notes so that you have all the examples to do your homework, is this one's already pre-factored. So that's a little bit trickier on the end behavior part and easier on the actual zero part. So we need to know if our degree is overall going to be even or odd. And again, is our leading coefficient positive or negative? Now, we did talk about this a little bit in class, that they could throw curveballs your way. Like putting a squared inside one of these parentheses would change how we count the multiplicity because it would have 2 answers inside there instead of just a 1. So as long as your bases have x to the first and then they raise it to a power, all you have to do is count up the multiplicities. That's going to give you your overall degree if you were to FOIL it out. And that's all we would ever give you. We're not going to try to trick you. But if they say one of these was an x cubed or an x squared inside the parentheses, that would be different. You'd have to consider how that would FOIL out, especially if it had a power on the outside as well. But ours are going to be pretty straightforward. So this is 3 plus 2 is 5 plus 1 is 6 plus 1 is 7. So 7 is odd. So if we were to FOIL out this entire thing and multiply everything out, which we don't want to do, it would have x to the 7th as its leading power, the highest degree. And then it is going to be positive. Now, again, they could trick you on that if they change the order. If this had been 4 minus x, we would need to pull that negative away from that parentheses because we don't ever like our x's to be negative. But since all of our x's look like they don't have a negative in front of them, this is, you can go with the sign up front, so it's positive. So odd positive means down on the left, up on the right. Okay, we've already got all of our zeros here. You just need to solve each one of these, see what would make it equal 0. Put them in order in our chart from least to greatest. So -1, 0, 2, 4. -1 came from this factor, which has a multiplicity of 2. 0 came from the front, which has a multiplicity of 3. And then the 2 and the 4 both came from factors that have multiplicities or repeating terms one time. They each only appear once. A 2 is a bounce or a cross, or not a cross, sorry, or a touch. I'm trying to talk and write. 3, 1 are all crossing the x-axis. There is a difference, and it just depends on whether you can even see it when we do this in WebAssign. But a 3 or a 5, so a 3 or a higher odd, when it crosses, it's going to cross sort of like x cubed. So it could look like this or this, depending on which direction it's heading. When you have a 1, which is also an odd number, it crosses more like a line. So it crosses kind of more linear. Okay, so that's the only difference. They both cross. This anytime you're 3 or higher though, and you're an odd, not an even, because evens are going to bounce or touch. That's when you get this little slight curve like an x cubed. And again, if you're not zoomed in really good on some of these, you can't even see it on the graphs when they are like multiple choice problems in WebAssign. -1, 0, 2, and 4. We're down on the left, up on the right. At -1, we're supposed to bounce or touch. That means don't cross. So you're going to go back down into the negatives, come back towards this next point. At 0, we're supposed to cross, and I want to make it cross sort of like x cubed, but it's hard to do. So it's crossing more like an x cubed than a standard curve. And then at 2, we're supposed to cross. And at 4, we're supposed to cross. So again, we don't know these exact heights. We just know what the general shape is. So it looks like f of x is going to be greater than 0 or less than 0 in the following location. So I'm just going to read from left to right. From -∞ to -1, we're below the x-axis. From -1 to 0, we're still below the x-axis. From 0 to 2, we're above the x-axis. From 2 to 4, we're below the x-axis. And from 4 to infinity, we are above. Okay, so that finishes up this. I'm going to post the video and the notes, and I will see you guys in class on Tuesday.